Welcome to a brand new explainer. Today, we're diving into something truly epic. We are going on a cinematic journey to explore the 7,000-year evolution of cotton yarn. We're going to trace this incredible, sprawling story from its very origins in ancient mechanical alchemy, all the way to the ultra-modern, high-tech manufacturing ecosystems that literally spin the fabrics of our contemporary world. It's a story about a relentless human pursuit of perfection in a single, enduring thread. So let's get right into it. Here is our strategic roadmap for today. We'll start with history and legacy, move into quality evaluation, trace the production evolution, break down ring spinning, explore rotor and vortex tech, and wrap up with comparisons and the future. All right, Section 1, History and Enduring Legacy. Before we geek out over modern machinery, we have to look back. Picture this. Archaeological evidence shows us that around 5000 BCE, and honestly probably even earlier considering we found mineralized cotton fragments hidden inside copper beads in the Indus Valley, ancient civilizations in both India and Peru completely independently discovered the mechanical potential of this plant fiber. Fast forward a bit to the 17th century, and Mughal emperors were actually throwing away heavy silks in favor of a translucent Bengal cotton called mulmul, just because of its incredible strength. Then the 18th century hit, and we saw a massive, seismic shift. Britain's absolute hunger for yarn sparked the invention of Arkwright's water frame, Crumpton's spinning mule, and by 1793, Eli Whitney's cotton gin. These inventions mechanized production and basically built the industrial engine that would completely redefine global trade forever. Now, we have to be absolutely clear and impartial about the historical reality of this timeline. Cotton's global expansion absolutely fueled the Industrial Revolution, creating immense wealth and pushing technological progress forward. But that exact same expansion was deeply intertwined with profound socioeconomic disruptions. The insatiable demand for raw material fueled the machinery of colonialism and directly intensified the institution of slavery, especially in the Americas. So cotton's history is inextricably linked to both massive human innovation and terrible human disruption. Moving right along to Section 2, Evaluation of Yarn Quality. We're moving from history to mathematical certainty here. In today's industry, high quality isn't just an accident, it is strictly engineered. Today, we classify raw bales using high-volume instruments, right? These measure fiber length and strength instantly. Then the APHIS system steps in to isolate individual fibers, hunting down immature threats, these tiny little knots called neps that can completely ruin a finished fabric. And this is crazy. Every single evaluation is conducted in precise thermal equilibrium under strict global ISO 1390 standards. Out on the production floor, systems like the Ooster Sentinel provide real-time monitoring. They catch spindle deviations the second they happen, scrutinizing mass variation and hairiness down to the absolute micron. So what does this mountain of data actually mean? Well, enter the Yarn Quality Index, or YQI. Think of this as the ultimate metric. It's a specific formula that acts as a unified standard, mathematically synthesizing everything, like how strong the yarn is under tension, how much it can stretch before breaking, and how regular its structure is, all into one single value. It is the definitive way to quantify the perfection of a spun thread. All right, Section 3, Evolution of Production Processes. Let's map out exactly how a raw, fluffy plant fiber physically transforms into refined yarn. It's basically a highly coordinated mechanical ballet. It kicks off in the blow room, where compressed bales are opened and cleaned, liberating the lint. Then we hit carding, which is often called the beating heart of spinning, where entangled fibers are individualized into a super thin web. Now here's a crucial split. For standard carded yarns, we just keep moving forward. But if we want premium combed yarns, a highly precise combing machine steps in to aggressively extract short, weak fibers called noils. After that, drying and roving parallelize and gently stretch the fiber strand. Finally, we reach spinning and winding, where the fiber gets twisted for strength and packaged up. It's fascinating to compare how this process has evolved. In the conventional era, mills ran on the unyielding grit of manual labor. Human hands were literally the primary sensors. People were feeding mechanical hoppers, hauling heavy cans in isolated batches, which obviously made things super vulnerable to inconsistency. But contrast that with the modern era, the smart spinning mill. Today, we've got robotic bale pluckers extracting micro-tufts with just flawless precision. Fibers shoot through closed-circuit pneumatic ducts, totally shielded from contamination. Automated guided vehicles seamlessly transport materials across the floor, while real-time electronic sensors correct mass variations in heartbeat. Today, it is all about seamless material velocity. Which brings us to Section 4, the ring spinning benchmark. If you want to talk about textile excellence, ring spinning is the sovereign standard. It's a true legacy of precision. Here's how it works. A drafted fiber strand passes through a tiny C-shaped metal clip called a traveler, which is flying around a ring on a high-speed spindle. The twist and the winding happen simultaneously in this tight mechanical embrace. This crazy precise tension within what's called the spinning triangle creates a highly ordered cylindrical helical structure. Because those fibers are perfectly aligned and tightly twisted, ring spinning delivers absolutely unmatched tensile strength. And the numbers back this up. When we look at tenacity, which is how we measure this strength, the differences between the systems are stark. Rotor spinning sits a bit lower, but then you see the jump to conventional ring spinning. But look right at the top, compact ring spinning. This is a brilliant advancement of the traditional ring frame that uses vacuum air streams to physically condense the spinning triangle right before the twist happens. The result? You get a yarn with this luminous luster, practically zero hairiness, and incredible tenacity. For premium luxury shirting and high-end bedding, this is absolutely the ultimate choice. Next up, Section 5, Rotor and Vortex technologies. If ring spinning is about traditional perfection, these systems are about high-speed aerodynamic marvels designed to completely bypass the old roving stage. 150,000. Let that sink in. That is the mind-bending number of revolutions per minute achieved by high-speed rotors in open-end rotor spinning. Instead of a traveler on a ring, centrifugal force blasts fibers into a V-shaped groove spinning at unimaginable speeds. It creates this very unique, fasciated architecture, basically a twisted core armored by disorganized wrapper fibers. Now, sure, it doesn't quite have the tensile strength of a ring yarn, but this bulky structure gives it superior absorbency and amazing abrasion resistance. So for durable denim and heavy towels, it is the unrivaled champion. But what if we push the speed even further? Let's look at Murata Vortex spinning, or MVS. This is a total aerodynamic revolution. Vortex uses high-speed air jets swirling around a stationary spindle to twist the fibers. The delivery speeds are just staggering here, up to 500 meters per minute. That's almost 20 times the speed of a traditional ring frame. And the high-velocity vortex actually acts like an aerodynamic comb. Through this really cool process called air singeing, it basically sucks away all the loose, short fibers. You're left with a highly polished surface that is incredibly resistant to pilling. For modern, performance athleisure wear, MVS is the absolute premier choice. Finally, Section 6, Comparisons and Future Innovations. Looking at the technical metrics, it's super clear that every system is a calculated trade-off. Think about it. If you're weaving luxury apparel, you are more than happy to accept the slow delivery speed of ring spinning, just to get that high tenacity and incredibly soft feel. If you're turning out rugged denim, you want rotor spinning for its fast speeds and toughness. But if you need super low hairiness and maximum productivity for sportswear, Vortex is your go-to. Manufacturers aren't just buying machines at random. They are highly strategic, matching the mechanical architecture of the machine directly to the soul and the function of the end product. But hey, the future of this industry isn't just about going faster. It is fundamentally about sustainability. We are watching a massive shift right now from a linear production model, where traditional harvesting just creates huge amounts of pre-consumer waste, toward a true circular economy. And what's really fascinating here is that open-end rotor spinning stands out as the absolute premier vehicle for this closed-loop system. Because it skips that delicate roving stage and relies on intense centrifugal blending, rotor machines can effortlessly handle mechanically shredded recycled fibers. We're talking about spinning up to 100% recycled cotton into the threads of tomorrow. And that brings us to the era of Spinning 5.0 and Industry 4.0. We aren't just spinning yarn anymore, we are managing fully integrated, self-optimizing data ecosystems. We literally have machine learning algorithms predicting the wear of a single gear before a defect is even born. AI-powered machine vision cameras are inspecting fabrics in real time, classifying microscopic flaws that human eyes could never even see. Automated doffing systems have pretty much eliminated human error on the floor. And even outside the factory, biotechnology is hard at work yielding drought-resistant cotton strains. AI analytics and digital integration are ensuring that the mechanical pulse of the world never ever skips a beat. Which leaves us with this final thought. When you look at the whole picture, from ancient mineralized fragments in the Indus Valley to AI-powered aerodynamic vortex jets, cotton's journey is just a stunning testament to human ingenuity. So, as we fully embrace this new era of spinning 5.0 and the urgent push for a circular economy, how will this relentless pursuit of perfection in a 7,000-year-old fiber continue to reshape the fabric of our future? It's a fascinating question, and the best part is we will all literally get to wear the answer. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.